Okay, so today we're going to be talking about absolute value equations, and we're going to talk about inequalities. I think the first thing is absolute value means a distance from zero on a number line. It actually could be from the origin if you have a graph. A distance is positive. The smallest distance we can talk about would be zero. And so a length cannot be negative, and you know that from geometry. And so we want to write an equation about absolute value. We would say the distance from x to 0 is 4. Well, you would write the absolute value, okay, is equal to 4. And the answers to that would be, well, you could stand on a number line at 4, okay, or you could stand at -4, and either way, your distance from 0 would be 4. So x is equal to plus or minus 4. And you can have a decimal, as an answer as well, or a fraction. Where would you stand if you said that your distance from 0 is 1.5? Well, you would stand at 1.5, or you could stand at -1.5. And either way, you can write x equals plus or minus 1.5 to be fast. So in class today, we talked about hey, go to the board, try to find some answers, without solving algebraically. But I think the big thing is, some of the problems are going to be tricky where you're like, well, I actually need to know an algebraic way to solve it if I can't kind of figure out the answer. So sometimes when you find an answer, both will work. One of them will work, the other one doesn't. It's called extraneous. Another one would be there actually is no solution to a problem. And let's talk about that first. If you notice a negative sign on the right side of your equation or of your inequality, once you isolate it, okay, isolation is going to be the first step in any of these questions. So isolate the absolute value. The first question, you're going to plus 18 to both sides. So once you isolate it, you should look at it. Okay, is this possible? Okay, I wrote in the class today, is this possible? Write down, is it possible? If you say, okay, I want my distance equal 15, can your distance equal 15? Is that a possible thing? If you get isolate, you're like, oh, 2x plus 5 equals, -6, you're like, I can't do that. You'd write there's no solution. Even if you made two cases and found answers, neither one would work, because if you double a number and add 5 and then take the absolute value, you'll never get -6. So if your answer says negative on the right side, it's either going to be no solution or all real numbers will work. And so check it out and think about it, and try a number and see if it works. Like try 0, see if it works. In this case, example A, yes, you can isolate and get 15. Your distance can be 15. And the way that you find the solutions would be you set the absolute value, drop the cape, drop the absolute value, set it equal to 15, and drop the cape, drop the absolute value, and set it equal to -15. Solve both of them. And the first one, you're going to get x is 5. Minusing 5 divided by 2. On the second equation, you minus 5, you get -20, divided by 2, you get x equals -10. You should check to see, are these true or are they extraneous? And you check it in the original inked question, that I give you as a start. So try this. And how you try it is you plug in x is 5. So if you plug in x is 5 here, so you double 5, you get 10. 10 plus 5 is 15. Then you take the absolute value, you get 15. And 15 subtract 18 does give us -3. So that checks. Try -2. You can do 2 times -10, you get -10, plus 5 is -5. The absolute value is good. I lied. That's -20, and the -20 plus 5 is -15. The absolute value of -15 is 15. And 15 subtract 18 is going to be -3. So both of these work. I think sometimes when you check things, you'll get 5 equals -5, and that's not true. Okay, $1 trillion versus -1 trillion, that's kind of the different, you're just kind of talking about a concept, but they're not the same value. And so check to see if it works. In the second problem, you have to isolate the absolute value. So you can minus 3x from both sides. That would be a good first step. And then you cannot distribute into an absolute value wall. Okay, you cannot. Another thing that you should know is that an absolute value is a PEMDAS grouping symbol. And so it doesn't make all the signs inside of it positive. You have to do the math inside of it, and then you take its absolute value of the resultant answer. Okay, so if you see -5 plus 2, you would do the math of this. You get -3, and then you take an absolute value to get 3. It doesn't give us 7. Some people think that absolute value makes everybody inside of it happy, like Disney World might do. But no, you have to do the math and then take its absolute value. And so on the second problem, you get rid of the 3x, subtract from both sides, divide both sides by -5. You cannot distribute into an absolute value sign. And you would get absolute value of 7x minus 2 is equal to -2. Wait a minute. Whenever you get a negative on the right side, it's either none or all. Can you have a distance equal -2? Well, no. So that's no solution. And so you would write no solution. Okay. And so good job so far. The next thing we're going to do is isolate. And so the sucker thing to do, okay, is to subtract 5 minus 3. The truth is we're trying to get PEMDAS. We have to use PEMDAS as we're solving. And if you ever had, I can read a pen. If you did 5 minus 3, parentheses, x plus 1, if you did 5 minus 3 first and then distributed 2, that's not true. You're supposed to multiply first and then subtract the 5. Okay, so you'd have to distribute another 3, and you don't do 5 minus 3 first. But on this one, you can't distribute into there. So what are you supposed to do if you're supposed to isolate this absolute value? Well, the first thing you do is you're going to minus 5. The second thing you're going to do is going to be divide by 3. Okay, and the third thing is, hey, is this possible? Can your distance be 4? The answer is, of course. Set the absolute value equal to 4 and to -4. So you drop this little absolute value cape. So you do 2 plus 2w is equal to 4. 2 plus 2w is equal to -4. Solve this thing, and you're going to get w is equal to 1. Okay, minus 2, and then divide by 2. You get w is equal to -3. And if you check each of those in the original problem, okay, they will both be true. The last one here is a little weird. Isolate the absolute value. Done. Is it possible? I don't know. The right side says 4w minus 8. It kind of depends what w is. Or x is, to see if it's going to work or not. So likely if you've got a letter on both sides, one in, one out, one will work and one won't. Not always, but a lot of times that's the case. So you isolate it, which we did, and you set it equal to the right side, and you set it equal to the opposite of the right side. So you do x plus 10 equals 4x minus 8. And then you also do, and you should write the word or between each of these things, or the other thing is going to be x plus 10 equals the opposite. So the opposite of 4x minus 8 would really be -4x plus 8. So if you solve each of these problems, you're going to get x is equal to 6 on this one. And if you solve this problem here, you add 5x to both sides, subtract 10, you're going to get x equals -2/5. And how you check it would be, you take 6 and you plug it in on the left side. 6 plus 10 is 16. The absolute value of 16 is 16. 4 times 6 is 24. 24 minus 8 is 16. So that checks. So the first one does work. If you try the second one, okay, you're going to get -2/5 plus 10. And that's going to give you what, 9 3/5? If you plug in -2/5 times 4 and then minus 8, you're going to get a negative answer. 9 3/5 is not equal to -9 3/5. So therefore, this is wrong. So you're going to cross it out. So always check to see, especially in ones that have letters on the inside and outside of a problem, to see if you get an extraneous solution. Okay, so the next part we're going to talk about would be, what about with inequalities? Okay, how do you solve things that are inequalities? And I forgot to grab, oh, here it is, here's us. Word problems. In word problems, to find the difference between things, you always subtract, okay? And, when you were younger back in geometry, you took two locations on a number line and you put a subtraction sign between them, and then you took your absolute value. That's how you find the distance between things. So think about this. If you're running a race and you're at mile, 2 and your friend's at mile marker 10, okay, how far apart are you? Well, you're 8 apart. So if you minus the two locations and then you make it positive, and then you're going to be okay. Because if you did 2 subtract 10, you get -8. Well, the distance is going to be 8. So put a subtraction sign between the two locations and then take the opposite value and you'll get your answer. So on this one, they're saying, okay, if you are in politics, you say you normally do a poll. Okay, not always, but for the big elections, for the important elections, you might do a poll and you say, hey, how are you likely to vote? And you try to predict, what do you need to do? Are you likely to win? Are you not? What's going on? Well, they said that the likelihood of them winning is 44%. And so they're like, but their errors could be off by 5%. Okay, so to find distance, you're going to subtract, and then you take the absolute value, because no matter which way you subtract the two values to find their distance, you minus the values, and then you say, okay, let's take the absolute value, because that's going to be the distance between the two places. So if you say that the poll says you're going to have 44%, well, then that means that it could deviate from there. So whatever you end up getting, subtract from 44, the distance between those, whether it's above or below, could be up to 4, okay, plus or minus 4, or 5, pardon me, from those values. So this is, what they expect, and this is what you would actually get. And if you minus the two values, you will see that the distance is equal to 5. So you can kind of tell, you could solve it algebraically, or set it equal to 5 and set it equal to -5 and solve to get it. But you could also say, like x minus 44 equals 5. I don't know why this isn't writing x plus 40, I lied. A lot of kids are like, you switch that. No, you switch. It's x minus 44 still, it equals -5. That's what you switch, the stuff on the right. And then if you solve that, you get x is equal to 49. And you get x is equal to 39%. I'm not sure why this is not writing for me. But let's try it again. So you can hear me verbally. From 39 to 49% is going to be, if you could add or subtract from 5 from the token value, that's going to be your range. And so absolute value helps you find distances, helps you express the equations, and then we're going to talk about it as an inequality in a SCOSH too, because I think it's important. You'll say, well, our distance can equal a specific value, but it also can be less than a certain thing or greater than a certain thing as well. Here, now it's working. Okay, so if we move here, we're going to talk about, okay, what if you want to have a distance smaller than something, okay, or distance greater than something? And the two ways that I express that would be, if you have a puppy and you put your puppy on a leash, or put it in your backyard, you want to keep it within a certain distance of you, or a certain distance of your home, so that it doesn't run away, okay, or get taken by somebody else, or whatever other male thing that could happen to your cute little puppy. And so a less than, I say, is like a leash. Okay. You want to keep it between certain values. Now with numbers and with, your puppy, it's not just saying keeping it to the right close into you. You also want to keep it on the left close into you as well. And so if you isolate your absolute value, you always have to isolate first, then look at it. If you see that it's going to be less than or equal to, yes, those go together. And so we want to first isolate and then say, if it's less than, let's see if we can write an inequality that expresses our situation. And I think the easiest way to do that would be like this right here. Okay. You take the absolute value, okay, that has to be less than, and you say, okay, let's put it in the middle and let's trap it between, the positive and negative of that case. And so you can do it as two cases here. You certainly can. Sorry, I had to cough. And so you can do it as two, and it's going to be and, because the values are going to be between that thing. Like again, your leash, your less than sign, you want to trap it between two things to keep it close, less than a certain distance from you. And so it has to be less than the bigger number, and yet it's got to also be greater than the opposite of that value as well. So on the negative case, you switch to inequality and you switch to the sign. I think the easiest way is, if it's numerical, is to put the absolute value in the middle and trap it between the positive and negative of that case, and then solve that. And I can show you kind of how you do that. Let's see, why is that stuck there? Anyway, let's see if I can scoosh up. There you go. And so less than is and, that's kind of the key word. I would say less than is like a puppy, okay? Like a leash. And so you can imagine your cute little puppy over here. And you're like, okay, you can stay between here and here. When we walk down the sidewalk, you have to stay between those values. And so your puppy can go between these two values here, and you solve it to find it. Now let's talk about the things that have no solution, or infinitely many solutions as well. If you think about it, with an equation, your absolute value cannot equal a negative number. So if you get something over here, you're going to write no solution. And if you get scared, like, wait, what's the deal? Try zero. The ones that equal or have a negative sign on the right-hand side, when you isolate them, are either going to be all or nothing. And so if you're like, oh, I'm so scared, I don't know what to do. Well, try zero. If zero works, then it's going to be the all real numbers. If zero doesn't work, it's going to be, hey, there's no solution, because nothing you try should work. So on equations, it's pretty straightforward if you can hold on to this in your brain to say, hey, no matter what's inside here, no matter what I do, if I add 3 or do something to it and then take its absolute, it's never going to equal a negative number. And so you'd write, hey, there's no solution. Your answer for X could be a negative value, but what I'm saying is when you isolate it, you can say there's not going to be a solution. So if you check your solutions, you will understand, hey, they won't work if you are going to do this right here. And so with inequalities, your distance, the smallest distance that something can be is 0. And so if it equals 0, there's going to be just one solution on the equal sign. If it's going to be an inequality, let's talk about no solution. I had the kids in class be like, hey, come up with something without cheating, to be like, can you come up with an inequality that has no solution? And so if you put in an inequality, I was like, what would you do? And so if you said less than a negative number or 0, it could equal 0, but it can't be less than 0. Okay, so less than or equal to -1 or just less than 0, those kind of things. So if you isolate it and you see a negative number on the right, check to see, is that no solution or is that infilling many solutions? And then the other thing I ask kids to do is like, can you just come up with a problem that would have all real numbers work? And so it's like, what would you do that would work for that? And so if you put a negative number on the right, think about what could you put here as a sign that would do that? And the answer is greater than. What do you mean? Well, put something here, X plus 3. No matter what you put in here for X, okay, it will be true that you add it to 3 and then you take its absolute value. That will be bigger than -1. Even if this was negative, like minus, 3. No matter what you put in for X and subtract it from 3, and then you take an absolute value of it, it's going to be bigger than -1. So if you see a negative sign or negative number on the right-hand side, once you isolate it, it's going to be all or nothing. And if you get scared and you don't quite know how to read it, try 0 and see if it works. The other ones, when you isolate it, if you get less than, we're going to trap it between a number and its opposite, which is like right here, and solve for X. And so if it has letters, then you pretty much need to do the 2 cases where you do put an and between them, like I showed you up here. But with numbers, you can pretty much slap it between those values. Let me see if I can find the next page here. Okay, here it is. So on the first question, we have to isolate it. And so get the absolute value by itself. And so we're going to -7 from both sides. And we are going to get -24. And then the next thing is going to be, we're going to divide both sides by -8. You can't distribute into an absolute value. It's like a wall, okay? With parentheses, of course you can distribute, but with an absolute value, you cannot, okay? So it's kind of like forcing it into a positive world and, shoving it in, like, go to Disney World, you'll be happy. No, we cannot distribute into an absolute value with a negative number. And so we can divide both sides by -8, and you get X plus 14 is going to be less than or equal to, remember, you divide both sides by negative, multiply both sides by negative, you get a positive. You have to flip the signs, and then to less than 3. So that says, hey, I want my distance to be less than or equal to 3. And because it's positive on the right, you can do it. Less than is like a leash, so you trap it between the number and its opposite. So trap it between 3 and -3. And then you say, okay, that's how you make a distance smaller than 3. You trap it between plus or minus 3 on a number line. And then we solve for X. What values for X would make that true? So you -14 from all 3 sides, and you get -17 is less than or equal to X, which is less than or equal to, let's see what we got, -11. So if you graph this, you're going to get the values between -11 and -17. And they're going to be filled in because they're equal to. And so less than if you pick values from between those values there, inclusive of -17 and -11, you're going to get answers that make that original problem true. And if you want to check some of them, you can. but less than means between something and something else. And also the and means it has to obey both rules. It can't just be less than negative 11. It has to be less than negative 11 and less than or equal to, and also greater than or equal to negative 17. It has to obey both those. A compound inequality, it says, hey, it's got two things going on, two parameters. The next one, if you plus 10 to both sides and then multiply both sides by 3, okay, you're going to get 16 then. And then multiply both sides by 3, you get 48. So you get 2x minus 8 is going to be less than 48. Again, I added 10 to both sides. I multiplied both sides by 3. And then I say, okay, I want my distance to be less than 48. Well, how would you do that? Well, trap the inequality between 48 and its opposite. Less than says I got to keep you within 2 parameters to keep your distance small enough. So you do 2x minus 8 is less than 48. And I want it to be, greater than negative 48. Okay, that keeps your distance small enough so that your puppy is safe. So you're going to plus 8 to both sides. And you get negative 40 is less than 2x, who is less than, what is this, if I can read my writing? 8 and 8 is 16, so we get 56. Okay, and then we're going to divide by 2. And so I'll go back up here to see it. So you get x is going to be less than 56, I believe that's 28. Yep, 28. Which is going to be greater than negative 20. So if you graph it, it'll be the values from 28 to negative 20, not including those values and shaded between them. Okay, so they should both be open circles. If you grab a value in there, it should make the original problem true. So less than will be trapped between something and something else, okay, to keep your distance small enough so that your cute little puppy is safe. Now, with the greater than ones, okay, the greater than ones, you think about like monkeypox or COVID or whatever, thing you're trying to avoid getting, we all don't want to get sick. But the thing is, if you want to be greater than a distance, you say, stay away over there or stay away over on the other side. If you're trapped on a number line, it's going to be, you stay to the left of me or you stay to the right of me. Okay. Assuming you can only move left and right. So greater has 2 options. Okay. And so on a number line, when you say, if you isolate and it's greater, you're going to say, and notice the or, okay? It's kind of like COVID or monkeypox or whatever you're trying to avoid. And you set the opposite value greater than the 1 value, or you have to write or, okay? Or you can be less than, you switch this inequality, less than the opposite value. Okay, think about this. If you're standing in the middle of a number line and you want someone to stay away from you, you want them to stay to the right of you, or you want to stay to the left of you, okay? And because there's no number that obeys both of those items, those parameters, you have to say or. You can stand here or here, okay? You can't obey both at the same time because numbers don't work that way, okay? And so there's no number that's, say, greater than 10 and yet also less than negative 10, okay? You can't use the word and. So it'd be or. One could stand it to the right or one could stand to the left. So you can do both of these methods by doing 2 cases, okay? And then on the less than, you put an and again, on both, you switch the sign. I like with numbers to do less than, trap it between a number and its opposite. With or, you can't do it that way. You have to do it as 2 cases and they will graph apart, okay? So that's just one thing you should know. And then they do that here and say, this is how you do it. You drop the opposite value, you do write it as it is, greater, and then you put or, and then you flip the sign and flip the sign from the original value. So you can try, we'll do a couple problems together. So if you isolate the opposite value, and I might need to change this one a little bit to make the numbers a little bit cuter. If we do this one, we minus 6 from both sides, and you get negative 30. Okay, I need a pen. Let me get the pen. So negative 30 is greater than or equal to 5 and then 2x plus 28. Again, don't distribute it into it. Technically, you can distribute a positive into an absolute value because positive numbers, when they distribute it and don't do anything, but you might as well divide both sides by 5 to make things smaller. So 2x plus 28 is going to be greater than or equal to negative 6. Again, when you divide both sides by positive, you don't flip the inequality. So greater. Oh, anytime you see a negative on the right-hand side, you should be dramatic and be like, oh, wait a minute, something weird is happening. And so it says be greater than negative 6. And this is going to be all real numbers. And if you don't remember why, And then you say, okay, well, what do you mean? I want your distance to be bigger than -6. Well, all distances are bigger than -6, okay? And so if you're still like, wait, I don't remember, well, try 0, okay? 2 times 0 plus 28, take the absolute value. Does that work? Well, yeah, 0 would work. Try another number. Hey, try 1. If you plug that in, yes, anything you try will work. So that means any real number will work for this problem, okay? And so just be alert for those things to happen. Okay, and the next one, if you -3 from both sides, and then you multiply both sides by 4, I'm going to change this to be a 2 so we don't get quite so many decimals. Okay, so if you -3 from both sides, you're going to get 2. Multiply both sides by 4, then you're going to get 2x minus 12 is going to be a greater than, that's going to be 2 times 4 is 8. Okay, so 8. And so then greater than 8. Well, remember, if it's greater, okay, to have a distance greater than 8, you can do that. And so how do you do that? Well, you drop the cape, drop the absolute value cape that you're wearing. And then you're going to write or, and then you're going to put 2x minus 12 is going to be less than its opposite. Always, always, always in your second case, you flip the inequality and flip the sign. And so then as we solve these, you're going to plus 12 to both sides. You get 2x is greater than 20. Divide by 2, you get x is greater than 10. Notice, remember, I changed the original problem because I didn't want fractions today. So you add 12 to both sides here. And then 2x is less than 4. So x is going to be less than 2. Now, you have to put an or between the answer. You cannot combine these as a single result, okay? On the other ones, the and ones, they're trapped between two numbers. They are written as a single problem between two values. On this one, you've got to keep them as separate because there's no number that obeys both. So x is greater than 10, or your x could be less than 2. Oops, that's going to be, let's make this a 2 and let's make that 0. So x is less than 2. Okay, so a number could be bigger than 10 and work, or a number could be smaller than 2 and also work as well. Okay, so you'd write this or this. And then the last one on this page right here is going to be, notice the letters on both sides. And so isolate the absolute value. Okay, that's done. And then it says greater. And so you do your two cases. If there's ever letters on both sides, you do need to write as two cases as instead of a single case, even if it's an and problem. So you would bring down the oopsie, I need a pen. Bring down 2x minus 5 and be greater than or equal to x plus 3. And then greater, this doesn't have the word or between it. Okay, if it was less than, we'd write and. And then we do 2x minus 5, and we're going to say it's going to be less than or equal to, and then we have to do the opposite of the right-hand side. So you can distribute a -1 to the right-hand side. And in this case, it just switches both sides to be negative x minus 3. And then we solve each problem. Okay, so if you bring x to one side, you're going to get x. Bring the 5 to the other side, you're going to get greater than or equal to 8. And the other part could be, you're going to add this, you're going to get 3x, and you're going to plus the 5 there, and you get less than or equal to 2. So x is less than or equal to 2/3. Those are your two parameters. And if you graph them, they're going to go apart from each other. And so I think the big thing is isolate the absolute value, look to see if it's an and or an or. If it's less than, it's between two values. Or you put the word and between your two inequalities that you write. On the second case, you always flip the sign and flip the signs of the right-hand value to get your two results. And then if it's less than, it's going to be between two things. If it's greater, it's going to be going away from each other. Example 2, with word problems, honestly, I don't think this is terrible either. If you read it, it says, hey, 58% of adults eat at a restaurant once a week. You're like, okay, cool. But they think they could be off by 3%. Okay, so to figure out a distance, you're going to subtract. So you say, okay, well, how many people actually do? Well, you're going to subtract it from what they think. And they say, okay, within 3 percentage points. So you could set equal to, but a more precise way would be 3. Okay, so, and then that means if you solve this inequality by like, hey, it's less than, you could write, it's trapped between 3 and -3, being the distance from there. If you add 58 to all three sides, you're going to get, the percent of people of Americans who eat at restaurants once a week is going to be between 55 and 61%. And the truth is, you could write this, or you could kind of, like if I say, hey, write an inequality, well, you could write that, but you can kind of see the answers just because you're a logical person. And that's okay with me to not necessarily show your steps of solving such an easy problem, but there was both a logical way to find the answer as well as, a numerical way to solve it as well. All right, thanks. Have a good day.